Today's topic is absolute value inequalities. We've already learned to solve inequalities in one variable, and we've learned about compound inequalities, so make sure you know those two topics before you tackle this one. Let's go back for just a minute and remember the definition of absolute value. Absolute value literally means distance from zero. So when I take the absolute value of 5, if you're looking on a number line, for instance, the number 5 is exactly 5 units away from 0 on that number line. That's why the absolute value of 5 is 5. If we're looking at the absolute value of -8 on a number line is exactly 8 units away from 0. So the absolute value of -8 is 8. Since distance can never be negative, when you take an absolute value, you always get a positive result because you're talking about distance. So we're going to start by looking at some basic inequalities involving absolute values. Let's start with the absolute value of x is less than 4. This is asking us to find all values less than 4 units away from 0. And the easiest way to figure this out is to draw a number line. If I'm looking at values to the right of 0, or the right half of my number line, the values that are less than 4 units away from 0 start at 0 and go all the way up to, but not including, 4 itself, right? Everything in the shaded area is less than 4 units away from 0. To the left of 0, I would start at 0 and go all the way out, but not, or go out to, but not including -4. So everything in between -4 up to +4 is going to be less than 4 units away from 0. I can write that as a compound inequality. I can write it as one statement, or I can write it as an AND statement. Of course, the single statement is more correct when you're talking about compound inequalities and you're shading in between two numbers. But everything between -4 and +4 will fit our inequality. Let's take a look at a greater than example. The absolute value of x is greater than or equal to 5. This is asking us to find all values that are greater than or equal to 5 units away from 0. And I can change that statement a little bit. I can say all values at least 5 units away from 0. Or I could say 5 or more units away from 0. It's all the same. Let's take a look at what that is on a number line. To the right of 0, all numbers that are 5 or more units away from 0 start at 5, right? I couldn't include 1 or 2 or 3 or 4 or anything in between in that statement. But 5 is included in that group. 6, 10, 1,000, those would all be numbers that are 5 or more units away from 0. So I start at 5 with a solid dot and shade to the right. To the left of 0, the first value that's 5 units away is -5. -6 is more than 5 units away from 0. -10, -50, those are all more than 5 units away from 0. So to the left, I start with a solid dot at -5 and shade to the left. Everything shaded in blue now is at least 5 units away from 0 on a number line. I can write this solution as a compound inequality. Of course, this time I'd want to use an OR statement since I'm not talking about the values in between. these are values that are less than or equal to -5 or greater than or equal to +5. They can be in one or the other category, but they don't have to be in both at the same time. I am going to encourage you to take the time to draw a number line for every absolute value inequality. I promise you it will save you so much headache. And before we go to the next example, I want you to take just a second to compare our solution with the original inequality, because I think you're going to start to see a pattern. Our second inequality looks exactly like our original inequality, only without the absolute value symbol. The first inequality I wrote down, though, switches direction on our inequality sign, but also changes sign on the 5. Keep that in mind as we go through our next two examples. In this example, we're going to take it one step further, and we're going to have some subtraction inside our absolute value sign. The absolute value of x minus 2 has to be less than or equal to 8 units away from 0. Now, a lot of people get confused on this type of inequality. So we're going to try to simplify and break it down into a couple of different steps. First of all, we're not going to worry about the x minus 2 to start with. We're just going to worry about the less than or equal to 8 units away from 0. On a number line, this, or everything shaded in gray, is less than or equal to 8 units away from 0. So to solve this, I'm going to split this up into two separate inequalities. My values, everything inside the absolute value sign, has to be greater than or equal to -8, but they also have to be less than or equal to 8 to make this inequality true. Now I can solve each one of these inequalities separately. On the inequality on the left, if I add 2 to both sides, I get x is greater than or equal to -6. On the inequality on the right, if I add 2 to both sides, I get x is less than or equal to 10. This is my actual solution, not my first number line where I was just looking at the values that needed to be included, but down here the x is greater than or equal to -6 and x has to be less than or equal to 10. That's my solution. On a number line, if I graph x is less than or equal to 10, I would have a solid dotted 10 shading to the left, but I also need values that are greater than or equal to -6. Here's my solution. Everything shaded in blue are values of x that will make this inequality true. And of course, since it's shaded in the middle or in between our two boundary values, I can write it as a single compound inequality. One more example and then we'll be done for today. How about the absolute value of 2x plus 4 has to be greater than 8? So I'm looking for all values. Don't worry about the 2x plus 4 to start with. I'm looking for values that are more than 8 units away from 0. That means everything to the right of +8 and to the left of -8. That means that 2x plus 4 has to be greater than 8 units away or greater than +8, or it could be less than -8. Remember what we looked at before and the pattern that I said that you'd probably start to see? Well, our first inequality looks suspiciously like our original inequality, right? Just without the inequality sign. And the second inequality flipped the inequality symbol and changed the value on the 8. If you want a fast way to do this, you can remember that pattern, but again, drawing the number line is most helpful. Now I can take the time to solve both of these inequalities to get my solution. The inequality on the left needs to have 4 subtracted from both sides to get 2x is greater than 4. Then when we divide both sides by 2, I get x is greater than 2. The inequality on the right, when we subtract 4 from both sides, I get 2x is less than negative 12. Be careful with your subtraction. And when I divide both sides by 2, I get x is less than negative 6. That's my solution, and that's what I'm going to put on the number line. I can graph all values greater than 2 and all values less than negative 6. I can have my compound inequality or I can have my graph. They're both the same. Everything in the shaded area, if I put those values in for x, will make my inequality true. Okay, I think that's enough for today. Don't forget that you can rewind the video and look through examples again. But for now, I'm just going to wish you a great day, and I'll see you next time.